Now, can you see my screen? All right, so today we are going to discuss something about NoSQL. Then we are going to discuss HBase. Right? So, how many of you are aware of NoSQL? What is NoSQL in your opinion? What is NoSQL in your opinion? Yes? Is my voice feebly audible to you? All right. So, what is a NoSQL in your words? Is it something you write in your resume when you don't know SQL? Okay. So one answer is no need of writing a query. Any other? All right. So other than mentioning in the resume, there are multiple use cases of NoSQL. Basically, the most important criteria for a NoSQL database is distributed architecture. Just like the way we made a differentiation between data and big data solutions, similarly, normal databases and NoSQL databases, the biggest difference is a NoSQL database runs parallelly on multiple machines. Okay. Now, it runs parallelly on multiple machines, because of which there are multiple things that could not be provided so easily in these databases. And there were few things which had to be there in those databases. So you can imagine, when you distribute the data across the cluster, across multiple machines, you need to be able to identify each row with a number, right? No matter whenever you distribute things across multiple people, you should be able to identify each thing so that you can retrieve, display, delete, update, and you can do a lot of things. Otherwise, if you have not identified each row or each thing which you are distributing across the cluster, then you will not be able to pinpoint and manipulate and actually locate where is it, right? So by virtue of it being a distributed architecture, any NoSQL database, by virtue of it being a distributed architecture, it has got an identification for each of the record. Okay. Now, this record which we are talking about here, it can be a row, it can be in the form of key value pair, it can be in the form of, each record can be in the form of, um, how should I say, an object, use object. All right. But no matter what is the form of this record, it has to have an identification number, right? That is what is one of the properties of NoSQL databases. So most of these properties come from the behavior of distributed architecture. For example, most of these NoSQL databases have not been able to successfully implement all the features of SQL. Okay, therefore some of them remain as an object database only, and they have figured out that even without providing SQL, they can be useful. For example, MongoDB does not provide you SQL at all, while Cassandra does provide you SQL like language, and they provide you CQL and even an ORM. There's a Hector, there's a there is a I mean, what do you call, ORM application, ORM driver for Cassandra called Hector. That Hector takes care of lot of things. Okay, right. So basically, there are multiple kinds of databases which are called NoSQL. The common thread amongst them is that all of those databases are distributed architecture. And by being distributed architecture, you have to have an ID for each record. Okay. Whatever you want to distribute, you need to be able to identify it. Now, the next point is that it's not only SQL, that is just the name. As a history, NoSQL as was a Twitter handle. It was coined as a Twitter handler, and the founders, those people who are working on these kind of databases, they were in hurry to reach to a venue for the conference, and in the meantime, they quickly coined NoSQL as the Twitter handler, and that's how it became a popular. Now, every distributed architecture is planned such that it is horizontally scalable. Okay. Next generation databases, every database is next generation. So we can delete this definition. Okay. Not only SQL is one name which they give, and open source, yes. Now it is schema free. Sounds like it is a feature, but the thing is, most of the NoSQL databases have been designed for performance, as well as most of these databases are distributed in nature. All the databases are distributed in nature, and therefore providing a schema for distributed application is really difficult. Okay, is really difficult. All right, because that kills the performance. That kills the performance. Next is easy replication. Easy replication there has to be there. Then all of them come up with simple API, and they all manage huge data. And other important aspect of any distributed application is they have to run on commodity hardware. All right, just like anything that comes under Hadoop umbrella has to run on commodity hardware. Will it handle both structured and unstructured data? Yes. Some of the NoSQL databases actually handle structured data. For example, Cassandra gives you a full form of tabular. Similarly, HBase gives you a full form of structured data. So does MongoDB also. Okay. Using NoSQL, we cannot do operation on columns. That is not true. You can actually do lot of operations on column, far more than what you did in SQL. As a matter of fact, most of the tables in HBase, they grow in both the dimensions. Rows also grow and columns also grow. You will see that as an example very quickly. All right. Now, so some amount of, basically it does not make a rigid schema. It is up to you how much schema do you want to define. All right. It doesn't force you to have that. Non-relational means that it does not comply with ACID properties. Most of the NoSQLs are not able to provide you the ACID properties of a transaction. All those properties which SQL provided, if you guys have heard about something called tuple algebra and something called Chord's theorem, all of those properties are not being met by most of the NoSQL databases. The normalization, foreign key, primary key, all of those functionalities are not, most of the NoSQLs are not able to provide that. Yes, transaction. So some of the databases handle transactions, some of them do not, and some of them provide you the functionality of enable and disable. Okay, so right now there are other important aspect is open source. Okay, now if you plan to build a database and you do not make it open source, trust me, you will not be able to sell this database at all. Not a single person will buy your database. Not even your cousin will take it and use it, right? If it's not open source, nobody is going to buy it. Therefore, almost every node database, because database database locks your database. Any data you push into database, you have to take out from the database with the database's permission. In case it cannot give you after point of time, your data is lost. Therefore, because of this fear, people do not experiment with the new database so easily, because there is a data lock-in. And therefore, the only way a NoSQL database or any new kind of database that comes into market or new database comes into market, they have to be open source, so that there is no fear of losing data. In case if there is a problem with the database, we can hire people, we can fix the problem in the code and get it out if it is the code is available, right? So that is the reason most of these databases are open source, and there are around 150 in the market. Now, why do we need a NoSQL? The important aspect is big data. When you have humongous data that cannot be processed using one machine, you have to go for either HDFS if your data is absolutely unstructured. If your data is structured, you have some structure in place, you would like to go for a database. All right. Second is high availability. If you have got humongous users parallelly, volume as well as velocity you have got, then you will go for NoSQL databases. Third is scale out architecture, meaning you know that today your users are few, but tomorrow your users are going to grow fast, and accordingly you will have to increase the hardware layer. You should not be in a problem that, oh, I can't increase the hardware. Our software can only run on two computers at a time or three computers at a time. It can't run on fourth. If you are in that kind of a situation, or if you are in a situation there moving from three to four, if you are in a situation, yes, scale out means horizontally scalable. Scale up means vertically scalable. Okay. So if you are in a situation that going from three machines to four machine is too much of task, you have to shut down, you have to recompile, you have to reclassify data, and then launch. If there is a gap of say half an hour between adding a machine, half an hour downtime for adding a new machine, that your architecture is not good enough. It is not good enough for an scale out architecture, right? So that is the reason why people go for NoSQL. Big data, as in high volume, high velocity, and as go as you uh, increase the hardware, increase the capacity as the demand grows. Now there are few NoSQL stores available, and they are broadly classified into four bullet points. So NoSQL database is actually, most of them do not qualify to be called as database. Therefore, I prefer to call them store. Okay. So most of the NoSQL stores can be classified into four broad categories. First one is the column oriented or wide column. Okay. So in column oriented database, they look like they have a rows and columns. And in document oriented databases, they look like an object store. They have a hierarchical object definition. They are not flat like tables. So they will look like, so on the top level you have TV shows has many TV seasons. Each season has many episodes, and each episode has many reviews and many cast members. So it's a complex object. It's a hierarchy of object that is to be stored. So databases which those databases which provide you the facility of defining a huge object to be stored, those are called document oriented database. Okay, these are object oriented database basically. Examples, most prominent one is MongoDB. Others are not, you may not have heard about them. Now there are third kinds, which is key value pairs. Key value pairs are the oldest form of NoSQL database. The whole story of NoSQL started from Amazon, from a database called Dynamo. During Christmas time, almost every e-commerce company suffers the shutdown. Every e-commerce company suffers shutdown because of the huge demand across the globe. So, in around 2003, Amazon suffered a huge loss, and then they decided that they have to overcome all of these problems. That's when their engineers started on reinventing database, and Dynamo was one output. Other than that, they bought a lot of hardware that time, so that if there is a so that they could expand to lot of hardware. But later on they realized that their NoSQL database actually solved the problem, and they started giving the hardware as a service to all the people. So EC2 actually is a result of Christmas chaos. Okay, the EC2 that exists at Amazon is a result of Christmas chaos that happened once. All right. So basically, Dynamo was the first of its kind when it comes to key value pair databases. And what do we have there? It's like a huge hash table which has a key and the value. Value can be a string or can be a binary value, but it used to be a simple string that time. And in case you have a complex object like TV shows, you will write it like you will you will write it like, say, movie dot name equals something. Okay, and then if you have movie dot, okay, let's say movie dot name in Hindi is, in English is this. Okay, and if you have in other language, you will put it movie dot name default language we call it. Okay, so basically we used to architect the whole application in the form of key value, the whole object. So here we have TV shows dot seasons dot episodes dot one dot reviews dot one. So this is, here goes my review. Okay, and similarly here, if we have something called ratings, done 1 is 1.0. So the whole object, whatever we used to write in key value pairs. That was Dynamo. So most of the key value pairs have been fairly replaced with a better version of them, so that value can be a binary object. Okay. Now, other examples of key value is Redis, which runs in the memory, and then there are others. Memcached is one kind of a cache. So if your website is slow, you generally put memcache so that you can create a distributed cache for other applications. Now there is a new kind which has come into play. One of them is the graph databases. Graph databases, for example, Neo4j, let you query the full full network. Okay, say for example, you want to find out who are the friends, how many friends are there which are 3 degrees separated from you and have black hair. So if you have to query that kind of, make a complex query which have to traverse the graph of object, that for that kind of role, uh, a graph database plays very well. Okay, so whenever you have to query a graph, so lots of complex structure can be easily represented in using a graph. The structures which you never thought could be represented, they are also very well represented in a graph. For example, if you have all the countries in the world and you want to find out where is the arbitrage possible, what does it mean by arbitrage? Say you have 20 currencies. First you convert $1 into 64 INR. Then you took these 64 INR and tried to convert it into Chinese currency. From there we tried to convert to Japanese currency, and after that we again convert it back to US. So this is a graph. Okay, This is a graph where we are trying to figure out how can we increase our money just by translating into each other. Okay, so lots of complex problems can be represented as graph. Even traffic lights, for example, traffic lights can be represented as a graph problem, graph or graph coloring problem. All right, so these are the four types of NoSQL databases. So Oracle is also used object oriented database. I'm not sure. But they are working hard on NoSQL databases these days. Is it chain processing? So it's not only chain, it could be you're talking about the graph processing, right? So there are same thing. So chain is like straightforward, but in case of a graph, you are given 2 points and you have to find a path, you have to find a fastest route, or you might have to find how can you disconnect using minimum disconnection of this graph, how can you make two subgraphs. So there are many complex problems that exist. For example, in Facebook itself, how are you connected to two people, how these two people are connected is something which is done using graph processing. There are many such applications. Even the PageRank algorithm of Google, which figures out how are how our pay is rating each other, how our pay is connected to each other is a graph problem. Okay, so this is a summary of what is NoSQL and what is SQL, and here you can simply see that it's a standard differentiation which says that there are many kinds of SQL databases. One type is, but there are only minor variations. Okay, so even in the SQL database there are many SQLs, but they are only of one type and there are only minor variation. They all have select statement, they have the same query constructs. It is just that some of them have a minor differentiation in data types, in defining how to do little bit of ordering, while in NoSQL, there are hundreds of database. So Pig and Hive you can say it's a SQL kind of a data store. Okay, but Pig is just a client. Pig does not store any data. Okay. Uh, Hive still stores some of the data, rest is in the file system, but it still stores metadata. Now, Oracle was founded in I think 1970, while NoSQL started coming in since 2004 or 3. Examples are pretty straightforward, we have already talked. And then model in SQL database, they all follow the same philosophy given by COD, while in NoSQL, there is no standard philosophy. Schemas, you have to upfront, even before adding a record, you have to first define the table and the columns. But in NoSQL, you don't define any of the columns. Scaling vertically, SQL databases can be scaled up vertically, and NoSQL databases can scale up horizontally. And any doubt about this point? Vertically, as in you will have to increase the RAM and CPU and all that. That's the only way of scaling. Development model in case of SQL database, there is mix. Some of them are closed source, some of them are open. While for most of the NoSQL databases, almost all is open source. Support transaction. All of the SQL databases have to support ACID transaction, but there is no such guarantee from NoSQL. Okay. Only certain circumstances and certain levels is what it does. All the data manipulation happen SQL, and in case of NoSQL, most of them have their own query language, or most of them have their own implementations. Consistency can be configured for strong consistency, and NoSQL, it all depends on which product we are using. And again, Hive is not categorized under SQL database. Why? Because there was no data manipulation possible. We could not create a record, update a record, delete a record. All right. So we cannot really classify Hive as a database at all. Okay. Hive was just analytics way because it provided us a way to query the existing data. All right. Let me just grab a water bottle. So yeah. Can you hear now? So can we say acid property etc are limitations for NoSQL? Yes. Some of them provide acid property, but that too very limited. There are many limitations, and the biggest form of limitation is the cap theorem. Okay, biggest form of limitation is in the form of cap theorem. Okay, so the truth is the truth is that in case of most of the situations when you demanded high throughput, as I gave you an example of Christmas time, and you must have seen the Flipkart story in the recent time when they ran a lot of offers. They all suffered because their platforms were not ready for handling that kind of users. So all of them have tried to move to NoSQL because that's what is possible, right? They had to get away from traditional database. I'll get into that. But when they moved away, they realized that there were few things that could not be catered to. Acid properties is one, and why is that? So the excuse, the reasoning why they could not provide those kind of things is given in the form of cap theorem. Cap theorem says that out of consistency, availability, and partition tolerance, a database can only give you two properties, not all three. None of the database can provide all three properties at the same time. All right. And why is it so? We are going to get into detail. Let's first understand what does it mean by consistency. Okay. Consistency means all the nodes. So you have multiple computers. So before you think about any of the NoSQL, you always think about there are multiple computers running. Okay. If you invented a database which looks like key value pairs but cannot run parallelly and cannot give you the scale out features, then your database is not NoSQL database. All right. So whenever you imagine a NoSQL database, you should imagine a cluster of computers, right? Now, so when we say consistency, what does it mean by consistency? So all the computers, all the nodes should see the same data at the same time. Okay. If you have multiple computers, so you can think that when you are reading, we'll be reading from one, and when we are writing, we'll be writing to only one. and it cannot be the same computer, otherwise the other computers of no use, right? Therefore therefore there is a need of consistency. So when people are reading, say I said my phone number is this, my phone number is 123, you stored that number somewhere. Now if somebody else comes and says what is Sandeep Giri's phone number, you will tell him it's this, right? That is the role of a database, right? Now after some time, when there is a lot of load and there are a lot of people like Sandeep Giri who are trying to tell you the phone number, and there are a lot of people who are trying to access Sandeep Giri's phone number, there are chances that you will have to distribute. And if you distribute, then one user might be reading from one database and other user might be writing to another machine, and that's where the consistency will get hurt. So one of the properties of databases is consistency, being able to provide this promise that all the nodes see the same data at the same time, all the computers see the same data at the same time, or all the clients, whether no matter which machine they are connected to, they should see the same data at the same time. So that is one. Second is availability. Availability means the system provides you a promise that no matter what, every request is going to be answered. Okay, that is availability, giving a guarantee that we are available, we will respond, we will respond no matter what. Okay. Third is partition tolerance. But what does it mean by partition tolerance? If you have three computers in your network, and even if one of them goes down, your system should not get hurt. If you have n computers and one of them is suddenly shut down, your cluster should still be able to respond without any loss. Okay, so at least one computer, if you shut down and still everything works as usual, that means you are partition tolerant. Even if you tried to create partition, your system was fairly fault tolerant. All right, now let me. Sounds good. Now, why is it that we cannot provide all three, consistency, partition tolerance, and availability, at the same time? Yes. So 2 and 3 are very, very well related. Yeah. But still we count them as separate. Right? Yeah. So as you can see here, out of CAP, if you see the traditional database, the first diagram, if you see the first diagram, it shows you there is one machine, there are two users which are trying to write or read the database, right? And this database can only provide consistency. Why? Because it's a single database. If one guy is writing some data into the same row which other guy is reading, the other one has to wait. Other one has to wait in the queue. And in case there are more readers, they might time out. And hence we have not provided a significant guarantee of response availability. Okay. Second, in case there is single machine, in case this shuts down, that means there will be no response, and hence it's not partition tolerant. So a traditional single database is neither available nor partition tolerant, is only consistent. Now, second one is Second one is partition. Second one is not consistent. Why? Because there are two computers. There is one person writing to one server. The data is getting transferred from that one server to another, and the other users who are readers, they are reading from other servers, which means there will be a significant gap between what you write and what users get. There will be a delay because data will take time for replication because of network, because of various kinds of reasons, right? Therefore, this is not consistent. And mostly most of the systems in case of NoSQL are of this architecture, which are non-consistent. They are called eventually consistent because after a point of time, after while, the data is going to get propagated and everything is going to be just fine. They are eventually consistent. Now, third kind of systems are of that form where users are reading from one machine, there is a replication going on. We keep on copying data to the backend, and in case either of the machine dies, either of the machine dies, there is one server available to respond, right? So if you can see that the third architecture is like of name node having a secondary backup. Okay. First one is your normal database. Last one is your second one is like a MongoDB. Third one is like a name node. Okay. So this one is consistent. Like name node is a consistent one, but is not available, not heavily available because there is machine which is a bottleneck. Sounds good? So probably this is the best explanation I could. This is the best diagram I could come up to explain cap theorem. Second one is there you had two machines. One of them is designated for accepting all the user rights. Whenever user wants to write, he'll be writing on this machine. Okay, and let's call it something. Let me call it A. Okay, and let's say we had B, we had B. Okay, we had A and B. Users write to A, the data flows to B, and all the users, there could be other users as well, which can read from B, right? Similarly, here we have A and here we have B. Okay. Now, do you understand the difference between the two architectures? Now, this architecture, if writing node goes down, if A goes down, the load shifts to B, the writing load also. Therefore, system is available. System is partition tolerant. If load shifts to B, system is partition tolerant. Sounds good? All right. Now let's move on. So this was the reason. So effectively, we cannot have all the three. This is impossible trinity. We call it impossible trinity. So Any doubt about cap theorem? Because the whole NoSQL thing, all NoSQL discussions revolve around cap theorem. All right, so it is clear to all. Now let's take a case scenario when you are building a highly available service. What happens in these kind of scenarios? Let me take you through a system. Let me walk you through a case study. Basically, it is the common case study with almost every service which is publicly launched. And this was actually the story of up to few years ago. Almost everybody suffered exactly the same way. It's a truth that everybody actually suffered the same way. At least I have at least 4 or 5 case studies which have the same path. So today you built a marvelous product. You are having a public launch, and you moved this application from your own personal workstation to somewhere, and launched it publicly, and you're pretty happy with your work, right? And after some time you start doing some PR, the service starts becoming popular, lots of reads start coming in, lots of people start hitting your server. At this point of time you realize, oh, what big deal, let's just cache things, let's just start caching things. Now what you do is you install memcached service. Memcached basically is a distributed cache, which is where you keep on writing to memcache the whole object. After reading from database, you push it to memcache and also serve it to the user. When the next user comes in, instead of hitting the database, it reads from the memcache. Okay, so memcache is a distributed cache, and we also start caching lot of common queries. If you realize that there is particular search query which users are hitting again and again, say for example, as soon as you open Gmail, okay, so there is one query that would be running called get the inbox of this user, or get the inbox of all the users. Now that query, if we start caching, right, it would be better, so that user does not have to wait. And effectively that also reduces your trips to the database, and hence making your database free. And caching is great. Caching sounds like the only option for 90% of the developers. Whenever people think about optimization, they either think about indexes in the database, or they think about memcache. Okay, this is for fact. Now the moment you start caching things, the moment is you start pushing data to a secondary store, okay, that means that you are not doing the work real time, which means since you are not going till the database, there are high chances that you are serving the users the stale data. And if you start serving this users the data from a cache which is prepared, you have you have you know voided the contract of acid properties. Acid properties say, can somebody quickly complete what do acid property mean? Perfect, perfect. So the answer is acidic property means atomicity, consistency, isolation, and durable. Those are the properties. And the moment you started serving the stale data via cache, that means you are no longer consistent. Okay, you are no longer consistent. Now let me answer one question by Satyanan. How many instances we will create for memcached as per the number of users? So generally the way you should be doing memcached is based on you should fingerprint you should fingerprint that how many requests are coming from the user and for which one. Find the common. So basically the way you should be doing is record all the queries which are coming from the user for a week, then find the top hit query, and all those top hit queries you try to optimize on which one is taking more time. If there is a query which is consuming few seconds of your database, you should immediately cache it, provided it is cacheable, it is not insert or update. Okay, you should never be doing insert and update via cache. Now you're fine, you are happy that you added a cache for some day, for some days, for maybe a month. If you are growing for maybe a month, you are pretty happy, but after a month, again, you are hit. You realize that there are too many writes that are hitting the database now. In step number two, you avoided the read request by putting memcache, but now there are too many writes hitting the database. You start doing a vertical scale up of your MySQL. Okay, of your database, you start doing beefing it up to 16 cores, 128 GB RAM, and banks of 15,000 RPM hard drives, and so on. A lot of it you start doing, right? Yes. So yes, you cannot cache every data because there is chance of going out of memory. Yes, that is why the distributed cache is there. So you increase the total number of RAM by distributing data onto the cache. But you always prioritize what is it that can be cached and what is it that can be served. Because what that should be served. It should not be that you start caching each and everything. You should be only caching the important stuff which has the higher demand. Now, you beefed up your MySQL and started doing a lot of development. You started adding features and features and features. And when the user comes for a simple work thing like get me the list of all the emails, you end up having so many joins. Okay, you start having too many joins. So let's imagine that earlier there was only something called in an email, there was something called only subject line. Now you came up with something called labels also. For labels you created separate table, and whenever user is hitting it, you join labels and the emails and then try to show it. Similarly, you start having something called colors. There is something another feature called favorite emails. Then there is a feature called uh, uh, I mean, let's say there is a one more thing you have added called priority, and so on. There are infinite number of features that are coming in, and you are implementing all of them. And when the user asks for the data, you have hundreds of joined together. And that point you realize that can I do something about it? Can I reduce the number of joins? And the only way to reduce number of joins is you basically put all of the data in a single table, right? And that's what we call doing a denormalization. Now you denormalized lot of things, and some of your senior DBA will go furious at the whole idea of denormalization, and you yourself will think then what's the point? What's the point of having a relational database? We are no longer consistent because we are caching data. We are no longer using standard database practices. We are not really utilizing the public key, foreign key, and joins. So then what's the point? And still, after doing all of this, you stop doing server side computations. Lot of things you were running in the stored procedures and in the SQL query, you stop doing that. Instead, you delegate those kind of works which are non secure, non does not require security. You start delegating it to the end user. Okay, so you start saying that let the JavaScript on the user side try to decipher this. Okay, now you will realize even after doing this, if your service is going popular day by day, you will try to do you will try to pre-compute or pre-materialize the data. Say for example, on the Amazon's website, the image you see, we keep it pre-computed. We keep lot of data pre-computed, that this is the data we need to serve. This is the whole page that we need to serve when user asks for this page. Okay, so we start pre-materializing lot of things in order to avoid the database lookups, right? Now you are able to solve things to a larger level here, but as but since as and when you are adding the data will get keep on slower, and because you will have indexes. Every time you write the data to a table, all the indexes are updated. And when you update the indexes, the total insertion time is close to log n or on. Okay, because data needs to get resorted, or you need to insert in a sorted data. So effectively, the bigger the data is, the slower the insert gets. And hence, you realize that if you drop indexes on the main table, then you save a lot of databases time. And that's when you realize that what should I do? What should I do now? And then you say that we should actually go to NoSQL. We are no longer using ACID properties. We are no longer doing a lot of SQL because we have started denormalizing stuff. So that's when this is the real database story. This happens with almost every database company. Okay, this happens with every every web server company. Now that's when you say that okay, enough is enough. We need to move on to a NoSQL database. Sounds good? No? All right. All right. So here it is. Now there is something called column oriented database. Okay. Let's get into what exactly it is. How does it look like and why do we need it? Okay. So a column-oriented database differs from a row-oriented database only in terms of how a data is stored. For example, let's take a case of this table which has got two columns. First column is employee ID and second column is employee name. Okay. Now, when you store the data, store this table onto disk, it would go like first row contains 10 and this is row oriented. Okay. This is row oriented 10 and Joe. Okay. Second row contains 12 comma Mary. Third row contains 11 and Kathy. While the storage in case of column oriented would be 10 goes into 001, 12 is part of 002. So 10, 12, 11, and then Jory, Mary, Kathy. This is how the data is stored. 10, 12, 10, 12, 11, Joe, Mary, Kathy. Here it's 10, Joe, 12, Mary, 11, Kathy. So this is the difference between column oriented and row oriented database. Okay. Now HBase is a column family oriented database. Okay. HBase is a column family oriented database. It's not row oriented column or column oriented. And how does it look then? Let us say there's a column family called CF1 which contain employee ID and name. Column family you can think of a group of columns. Okay. It's like a group of columns. And there's a column family 2 where that there is an edge. Okay. Okay, so you can think about these two are merged and we call it column family 1 and this is column family 2. Okay, this is how it is. All right, now let me draw the lines in it that will make a lot of difference. Okay, how do I why can't I see okay, whatever. So basically I wanted to show you that here an employee ID and name are part of one column family and age is a part of another column family. So the way the data is stored in a column family oriented database is everything which is a part of column family 1 is stored first and columns each column family is row oriented, which means 10 Joe, 12 Mary, 11 Kathy will be stored first and then 23, 33 and 45 will be stored second. Okay, so we stored column family 1 first and then column family 2. This is how it is stored in the disk. That is what it means by column family oriented database. All right, we'll see this after we look at how the data is stored in database in HBase. You will understand what do I mean by column family oriented database. Okay, now here, so this was about NoSQL in general. Now let's talk about HBase. Okay, what exactly is HBase? So the best answer is HBase is A column family oriented database. It it is based on a paper published by Google's Big Table. It is good when you have to do operation of read write on millions or billions of rows. Okay, hundreds of millions. It's not good even if you have a million rows. It's good only if there are 100 million rows. Okay, for up to 1 million rows probably your existing MySQL will be pretty good, or MS SQL will be good. But if you go beyond up to maybe the hundreds of millions, then you need a HBase or other databases. Okay, below that your MySQL will do pretty good job. And it is not eventually consistent, it is strongly consistent. Automatic sharding, as in there are something called region servers. Using that, it does automatic division of data. It does an automatic division of data without you having to specify that this is how the data need to be divided across the servers. And in case one of the server fails, it still keeps on working because there is a failover available. It has a strong HDFS integration, which means it will only run on HDFS. If you don't have HDFS, you will have to install HDFS before installing HBase. Now, it provides you the capability of running distributed computing in the form of MapReduce. Okay. The API it provides, API HBase provides, is in the form of thrift, which means that API can be in any language, whether Java, Python, COBOL, and whatnot. All right. There is a concept of coprocessors in HBase which are similar to your triggers on the backend. And then there are Bloom filters to optimize searching of the data. These are the few features of HBase. Okay. And these are few more characteristics. First, it doesn't have indexes. Although it is not a characteristic, it's a feature missing. But in maintenance of indexes is your problem. Database does not provide you automatic indexes. There is only one which is column and row which can be used as index. I will talk about that in detail. How do you architect your application such that I'll talk about Bloom filters, no worries. Okay. And all right, it scales linearly and everything we have discussed. Other characteristics are it runs on commodity hardware, it has a fault tolerance, and there is a batch processing. Okay. Now, this is the architecture diagram of HBase. All right. Now, you have something called HDFS. You have something called Zookeeper. Okay. We'll talk about Zookeeper also after this one. I'm not sure if that's a part of. A Zookeeper is not there. Actually, it's not needed. It's good enough, yeah. So, in HBase, you have HDFS where the actual data is going to get stored, and there is a service called Zookeeper which makes the communication between master and region servers. So, Zookeeper acts like a central agency. You can think of Zookeeper like a central file system via which master and region servers communicate with each other rather than directly master and region servers talking. They route their conversation through Zookeeper. Now, on top of these two services, there is master. What is master? Master is the one which takes care of talking to all the region servers. Master is exactly like our name node. Okay. Master is exactly like name node. Master keeps track of the metadata information, that what are the tables, what are the columns, what is the column family names, and so on. Okay. While region servers are the one which are going to store the data, and the data is in the form of H file, and and basically that H file is H file and memory store is stored using a write ahead log, which means you keep on writing to in memory, and that keeps on writing to the disk. So those are the few things. Is my voice breaking for all? Hello. Okay. Now HBase on the top of master reason is that it provides you an API in the form of in the form of your in the form of uh, thrift server. Okay. Thrift server is something which is very very common, and probably in your organization also, if you are building some service API for other teams to use, you should build using thrift. I've liked it as a framework. It's pretty stable, and it has come from Twitter. So you only write your API in terms of thrift intermediate language that get compiled into multiple programming language. So API is provided in almost every programming language supported by thrift. All right. So before we get into data model, let me tell you the title of the paper called Big Table. Okay. So the big table Big Table was the main inspiration of HBase. HBase was the direct implementation of Big Table. Big Table comes from Google, and based on which HBase was designed. And you can see as the definition of Big Table, where is here. This is the data model. Nothing else describes better than these few words. It says a big table is a sparse, distributed, persistent, multi-dimensional sorted map. You cannot take a single word out of this sentence. You cannot take a single word out of this sentence which doesn't make sense. Each and every word in this sentence is actually makes sense. You cannot remove a single word out of this sentence, and that's the beauty of it. So basically, when you have to describe the data model of HBase, it's the same thing. It is sparse. Can somebody quickly tell what is sparse? Sparse is opposite of dense, which means your database table is not densely populated. Some rows has only one column, first column, and some rows have only second, some rows have only third, and so on. So it's very, very sparsely populated. Okay. So big table is designed for the use cases when your data could be sparsely populated. Okay. Some rows don't have, because traditionally the database table were designed for the cases where table is densely populated. Okay. There could be the case that 90% of your whole table is actually empty. When you deal with big data, this kind of scenarios are quite common. Okay, so example of sparse is, I'll show you a table and you will understand what does it mean by sparse. Sparse means your table has say 1,000 columns. For first row, only last two columns are filled. Second row, only first three columns are filled. Third row, only middle ones are filled, and so on. Mostly the whole table is empty. So that is sparsely populated. Then there's something called distributed. What does it mean? The whole data is distributed onto multiple machines. Third, persistent multi-dimensional sorted map. Persistent, which means saved onto disk. Multi-dimensional, it has got various dimensions to describe the data. Okay, you have column, rows, and other parameters to define your data. And the next important keyword is sorted. Whole table is sorted by the row key. Okay, every row has got an ID, we call it row key, and the whole table is sorted by row key. Okay, so every table has a primary key, and by the primary key it is sorted. Okay, so and map as in it has got key value pairs. There is a key called row key, and value is any object which you can store in that. Got it? So that is the data model. And I'll go into more details of data model because out of all the things, it is the data model on which you will have to work the most, because you will have to design an application. And before designing an application, you will have to decide how many column families are going to be there, how many tables are going to be there, and how are you going to query the data. So this was the definition of HBase that comes from big table. In HBase, the biggest unit of data is table. HBase table organizes the data. The data is organized into HBase tables. Table names are string, that plain text safe strings, which can be good for file system path. Okay. Row of each table has got row, and each table has got row, and row has got identifiable row key. Every row is supposed to have a key, okay, by which we can identify each row distinctively. And row key are of the byte array, which means it's just bytes. Okay, which means it can store a number, a string, a object, a JSON object, okay, or a video file. So row key can be anything, not necessarily a plain text one. The way most of the hash table you saw earlier also, they all had plain text key. Remember when we were defining HBase, we are defining Hive data map data type, the key was always plain text. Here that's not the case. The key can be any binary types. Now you might ask, that if row key is a binary data, on what basis does it get sorted? Very plain answer is bytes are sorted. One zeros can be sorted. All right. For example, if you have binary data of this form, not this, of this form, this is smaller than, if you put a 1 over here, it's a smaller than this number is smaller than this one, and so on. Okay, that's how the data is sorted in case of row keys. Now the next part of the data you need to understand is column family. Each row has got multiple column families. You first define column families on the table label, saying I have got two column families, column family 1, column family 2. And in each row you have to store your data inside column families. Column families impact the physical arrangement of data. As we talked about, that HBase table is column family oriented data, right? Therefore, column family have an impact of physical arrangement of data. You have to define a column family while defining a table before starting to add any data. It's not that easy to modify a column family. So you be very cautious while defining column families. Um, and just for defining column families, you might have to work a little harder on your data model. Every row in the table, although every row is not supposed to have all the columns, every row can have new columns, every row can have only few columns, but every row is supposed to have the same column family. You cannot add extra column family in a new row, but you can add a new column in a new row. I'll show that part. You'll understand this. Okay. R strings column family is the name similar to table name. Column family is also a string which is safe to use in the file system. You cannot have binary data as the column family name. Okay. Now the next abstraction of the information is column. A column is essentially just another number. You can keep on adding more and more columns as in when you are adding data. There is no necessary that you add the same columns which you define. You never define columns at the time of defining tables. All right? You only define column families. A column family can have multiple column names. A column family can have multiple columns. Depending on our requirement, column family covers columns. Yes. Okay. We'll take few examples. And column name can also be bytes. Now note that thing. Row key can be a byte and column key can be a byte, and the value can also be a byte. The only thing that cannot be a byte is the column family name and the table name. Okay. Now for each row and each column, there is something called actual value. Actual values are stored in for row and column. That is called cell, right? It's like a huge matrix which has got row and column, and then you're adding the value there. Value can be bytes, which is quite common, right? Now for each cell, we call it cell, in which we store the value, the history is maintained. History in the form of versions, it is maintained. By default there are three versions maintained as a history. Okay. And the version id is timestamp. Okay. Version id is timestamp. If you are not specifying while writing, the current time is used, and if you are not specifying while reading the data, then the latest value is used. For each row and each column, we keep on storing the data, and this data keeps on getting versioned. Okay. By default, there are three versions being used, and later point of time, there will be more and more versions added. Column families are not like table name. Table name is there anyway. Okay. But you can think of multiple tables combined together, multiple tables of relational databases combined together form the table in HBase. Each column family behaves and looks like a table. The only difference is in the relational database table, we define column names. In case of HBase, we don't define table names. We only define column families. All right. Now have a look at this. Okay. Have a look at this. So this is the standard kind of a table. All right. Here there is a table. Okay. The table name is, what do you want to call? The employee information. Let's call the table name as employee information. The employee information has got row key, which is maybe the employee ID, and then it has got two column family. One is personal information, other is office information. In the personal information, you have got two columns. One is called name, other is called residence phone. Okay. Similarly, in the second part, you have got phone and address as two columns. And each of the value is called here. It's each one for each row key and each column. Say for 0001 personal colon name. So whenever we call a name of a column, we generally qualify it using the column family name. So here column family name is personal and the column name is name. So we call it personal colon name is the column name, fully qualified column name. So for each row key and for each information, we have got multiple values of cell, and these multiple values are historical values. Okay. All right. So this is how we can represent theoretically, but in reality, this is the physical view. If I have to represent it hierarchical, this is how I will represent. At the top, there is a row key. Under that, there are two folders called Office and Personal. Under Office, there are two folders called Address and Phone. And under Address, there is timestamp 1, and under the timestamp is our value. Okay. So this is a multiple dimensional way of accessing data. These are all dimension. For each row, for each of this column, for this column family, for this column, this timestamp, we have got this as the value. All right. So this is kind of a physical view of saying it. We will show you that when HBase stores data onto HDFS, this is how it stores. Right. Now, what is the point? What is the point of all of this? Was the point of having this kind of a complex data structure? So this is an example which I want to give you. Okay. So I want to take a break of 10 minutes and come back at 3:43. Back by 3:44 actually. Hi, I'm back. Are you guys in? Should I start? Should I start? All right. So let's take a look at how is the data of Google's crawler organized. Okay. So when imagine that you're building a crawler which needs to store a lot of information. So this is one example. How would you architect your data? What should be your row key? So what does crawler do? Crawler downloads the web pages and then it finds out what are the references from one page to another. It notes down all of those references. Under what name are those references? I say href equals this for this particular link, right? What is the name I'm calling any external reference? So all of this information needs to be stored somewhere. When we are downloading billions of website, where will we store such information? This information, who refers to who, is also very important because based on who refers to who, the page rank of various pages are created. If a page is being referred by many other pages, and then its rank is higher, and if this higher rank refers to some other page, that means that page has got higher rank than this one. So so that's how it happens in case of page rank computation. So to store, we are storing the data so that we can do a lot of things like page rank computation. All right. So for that, right? So as you can see here, the row key, since the table is sorted by row key, right? Row key has to be such that the data of two of the same company comes together, right? So a company called www.cnn.com can have another domain called www1.cnn.com or x.y.z.cnn.com. Therefore, if we store the row key had been the normal one, www.cnn.com, kind of thing, then the data of same domain would be at two different places. Therefore, what they did was they inversed so that the top level domain is in the beginning, and then second level, then third level, and then fourth level. This means companies with the same domain name will come together. Okay. Now let me enforce what I'm trying to say. So com.cnn.www and com.cnn.email, com.cnn.pages. Okay. So basically, instead of saying www.cnn.com, we are keeping this as the key. Why? Because our row key is our data is sorted by the row key. Now, if you see cnn.com, right? Now, these two will not come together. Why? Because there will be other data as well, and that data will get into this. Okay. if we have pages.cnn.com. Now our objective is to keep the data of same company together in in the table, right? And if we have row key which is closer for the same company, then it would make sense. Is it clear to everybody why we have kept this way? Instead of keeping this, now imagine this. Here there was something called email.indiatimes.com, right? So its key would be com.indiatimes.email, right? So this is our key. So when you are deciding upon row key, first you will think about which data do you want to keep together and how can you generate a row key such that the data which you have planned to keep together remains together. So we want to keep all the data from a company domain together. Therefore, we devised a key which is the inverse of your uh, domain name. Okay, so that is our row key, and then you have first column family called contents. Okay, so contents is one of the column family. Inside contents we could have html, inside contents we could have text, inside content we could have avi and whatnot, right? And these will be different column. There's one column, another column, and then another column. So contents is one column family, right? We are trying to store the data from multiple websites which are being crawled. Then we have another column family called anchor. Now anchor means, so we have anchor, and this page, our current page, might be referring to another pages. Okay, or vice versa. These pages cnsi.com are referring to our page as cnn, so we have kept that as the column name. So which means as and when we discover more and more and more and more domain names referring to our domain name, we keep on adding one column here, which means there are going to be a million column as well. Okay, if there are million people referring to our website, there'll be a million columns in this row, right? So which basically why what I want to convey to you that the way our row expands, we keep on adding. Traditionally in our relational database we have been adding rows one by one, right? We keep on adding rows into the table, but we do not add columns into our table at the base. Here in case of HBase, our table expands to both the sides. Our table has more and more columns in a column family, as well as our table has more and more rows in the column family. It's like big expanding matrix. Okay. Okay, let me explain Anchor again. So our website www.cnn.com has got some HTML content. It is being referred by another websites. So Times of India might be referring it. Some uh, BBC might be referring to CNN. So there will be a column called with the BBC name. Okay, anchor column. This is the name of the website who is referring. Note that the column name is not static, is the name of the website who is referring, which means there could be 1 million columns in this table, right? There could be a million columns in this table. Now, what is the value here? How am I referring? What is the name while referring it? What is the name am I giving to this website? That is our cell value. Okay. So if you notice, traditionally what we will do is we will just create one more column saying referred by, and we'll add one more row here, right? Here, that's not what we are doing. We are adding more and more columns, and as well as we are adding more and more rows. And that is the difference in the way you think when you decide on any HBase or kind of Cassandra kind of database. Okay. So cnsi.com is referring to www.cnn.com as CNN. My.look.ca is referring to cnn.com as cnn.com, and so on. Okay. When you refer somebody, you generally refer like this: a href itc.com. Okay. And then we say itc main. Okay. itc main and then slash a. So here our web page is referring to itc.com by the name of this one. All right. That name, this name is what we have here. Make sense to you? No? So when you think about it, took me some time actually. When I was building my first application in Cassandra and I was supposed to design the similar way, I always continuously kept on thinking in terms of we'll have these fixed columns and we'll keep on adding rows. Ideally, how would we design this kind of thing? How would we design this kind of thing? We'll have something called a table. This table will have one column ID called domain name. Okay, domain name. And then we will have another something called inverse domain name, or maybe this is, let's call it inverse domain name. Okay, and we'll sort it by the first one. If we are traditional designing, then we'll call contents.html. It's a huge varchar we'll say this much of data which we can put here, and then we'll have another column called txt, again same way. And if we have okay, if we have something of this sort, okay, like this. Okay, and after that we will have anchor, another column anchor, and that's it. Okay, and when we'll be adding, every time we'll be adding data, only one of these will be filled, these two will be empty. Either one of these will be filled based on what is the data kinds. Now, and they'll be in anchor. If we have multiple anchors referring to this website, or we'll have some different table 2, okay, in which we have ID and anchor name, we'll keep on adding into table 2, right? This is how we will design our table 2 and name of anchor, right? This is how we will design. Okay, or let me put it a proper one, like this. Okay, like this. And here you can say domain ID, which is a foreign key of table 1.id, right? This is how you will design it using relational database, right? But this one will not scale up for you. Okay, every time you have to find out what is the anchor, you'll have to join these two tables, right? And when you have to join these two tables, that's not going to work because it will take a lot of time to join these two tables and give the results. All right, are you guys with me? So this is how you will design. Instead of this, what you did was you merged these two tables. Whatever was supposed to go in table 2, we made that as a column which is expanding on the right side, and we are adding one column instead of adding a row in a separate table. We are adding one column in this table. All right. So you have to give a thorough thought when you are designing your data structure, your tables. Why? And while designing, you have to think about, can I utilize the fact that we can add infinite columns? So can we move some way of expanding to rows? Instead of expanding to rows, we can expand to the columns. All right. Because having a fairly sparse table is perfectly okay with HBase. Sounds good to you? All right. This is what it looks like. Again, let me reinforce. Indexing is based on row keys. Tables are sorted based on row key. First, these two statements are same. Each region of the table has sorted row key space. Okay, same again. So basically, a table is splitted into something called reason. Okay, these reasons are stay on multiple machines, and these reasons keep on getting splitted further. A reason is a subset of the whole table. It contains the the subset of the row. All right, subset of the total number of rows. And a reason is identified as start key and then end key, while end key is not included while defining. If I say my reason is 1 to 10, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, not the 10. Okay. If I say my reason starts with 1 and comma 3, which means 1 and 2, not the 3. All right. That's why there's a square line here, you see. Everything in HBase table is stored as bytes, which means you can store the data in the form of whatever you wish for. Okay. And which also means that there is a headache associated with deserializing your data. You could convert your data in JSON, and then you can create a binary out of it and save it there. Atomicity is guaranteed at the row level, which means when you are adding, updating, deletion in a single row, whether in it is in first column family or second column family, that is guaranteed. The atomicity is guaranteed. If you are making a change to a row, the intermediated changes will not be reflecting to end user. If as part of a single transaction, if you are modifying two columns, column 1 and column 2, there will not be a scenario where column 2, half of the changes are reflected to the user. There will not be a scenario, meaning column 1 modified but column 2 is not, and still user sees this state. No, user will not see this state at all, which means it is row wise atomic. Either the whole row changes or nothing changes. All right. Atomicity is guaranteed at a single row, not at the table level, not at the multiple row level. Which means, because in the traditional databases, the consistency, the whole acid properties are just marvelous. We could say, as part of a single transaction, insert a row into this table, update the row into the same table, and create another table 2, and then update some values in table 3, and you do it all of this in a single transaction. That kind of thing is not available as part of our edge base, right? Because if HBase starts giving that kind of facilities, where multiple rows, multiple table, and whatnot, then HBase will not be able to guarantee you the performance and availability. Okay. So column families need to be defined upfront while creating tables. Qualifiers are dynamic and can be defined at right time. They're stored as bytes, so you can even put data in them. All right. So basically, you have to put data in columns as well rows. It's as simple as that. The second dimension of finding the data is using columns, column name. So data model, whenever you are querying the data in this table, you get the data in the following order. The, First, the data is sorted by row key, then data is sorted by column family, then the data is sorted by column name, and then timestamp. With respect to timestamp, the data is ordered by descending order, while for rest, it's ascending. Okay? Now, there's something called reasons. Tables are automatically partitioned into regions. So you have a big table. By default, you will be creating a big table into one of the systems. There is a HBase master and there is a region. Region is where you store the first table. And you start increasing the size of the table. It will automatically split into two halves if the threshold of the table size has hit. Okay, it will split into two halves if the threshold has hit. Okay, a reason is denoted by the table name, its first row inclusive and last row exclusive. Initially a table is of single reason. As the table size of a reason keeps on growing, each reason can split into two halves, two equal halves. Okay, that means the reason is automatically distributed across the cluster. And more and more you keep on adding the data into table, the more reasons you will have across the cluster. Okay, and where does the physically, this is how the data is stored inside apps at base data. If you go into that, if you go into our say Hadoop, the data is stored in this place. Okay, inside apps hbase data default, you'll have at the top level table name, then reason name, and then column family name, and then store file name. Okay, so each table is broken into regions and each region is further having column family. Okay, so all column families are in a single region. Okay, so the data structure actually tells you a lot of things. This file system actually solidifies the ground on which we have been talking. So, so each table contains multiple reasons, and each reason contains multiple column family, and multiple column family stores the store file. Okay, because the data in a column family stays together, right? So all of this stores under multiple files. So here you can say go to HBase data, again data. Here there are other metadata is stored here. Okay, data, and here data default, and under this you can pick up any table. So we picked up my HBase table. It has got one reason, this one. This table has got one column family. Under one column family, one we have got the actual data stored onto the database. Sounds good? This is the binary data stored in that table. Okay, you can say view as binary or you can plain text and so on. All right, it is because store file is an object which is stored in system, which is binary data. Okay, rows update are atomic. Okay, then When you are querying HBase, you get a scanner as a result. Whenever you open a connection with HBase and query something, it gives you a scanner. Scanners are like cursor in a traditional database. Okay. And also note that by default, HBase does not provide you the SQL kind of interface. SQL kind of interface are provided by third-party libraries. Okay, HBase only provides you get and put methods and scan. So you first create when you are querying from Java, you will first create something called htable, which represents the table, and then you scan. Okay, and after scanning, you will get subset of rows, and on those rows you will operate. While creating a scanner, you'll have to specify a scan parameter, which is basically composed of a row number, starting row number, end row number, and which columns to return, and so on. Okay, so that is scanner. Now, how does the communication happen? Okay, and each invocation, once you are done with reading a set of rows, you can say get me the next set of rows, and then the trip goes back to it trips back to the reason server to get the data. Okay, now the architecture of our HBase is like this. You have got something called HDFS, where this file is getting stored. This final file is getting stored, as I showed you, because we are browsing here is HBase, of HDFS. Okay, so everybody at the end of day they store everything into HDFS, whether each region or the metadata. So master as well as region server, they all store the data into HDFS. Fine. Now, second one is the master and region server, they talk to each other using a service called Zookeeper. So if master has to find out how many region servers are there, instead of hard coded values, it basically asks Zookeeper that, hey, how many region servers do have registered with you? Okay, so and Zookeeper will tell master. And how does Zookeeper know? As soon as a region server is created, it comes it is told to inform Zookeeper. Okay, so all Zookeepers keep on giving its attendance. Sorry, all the region servers keep on giving the attendance to Zookeeper, and Zookeeper maintains that information. And whenever master asks Zookeeper how many of the region servers are alive, Zookeeper immediately informs, and based on that, master takes multiple calls. All right. So Zookeeper is like a big whiteboard on which all the region servers keep on writing. All the people keep on telling Zookeeper that, hey, I am here. So Zookeeper assists our master to have the really high availability. All right. Now, this is how the region servers look like. Some of the rows, so you have these row keys. Imagine they are from A to Z. Okay. And out of these row keys, there are six sections. There are six sections. Okay. And first section is on region server 1, and last section is also region number 2. Then there are these two sections, they are on these. So this keeps on happening all the time. The tables keep on getting splitted and keep on getting moved across the region servers. Okay, so this is the physical view of a region server. Now this is a quick code which shows that this is how you talk to the HBase and get the data. Okay, it says that we create a configuration first, HBase configuration, and after that you create something called HBase admin on top of config here, and after that you define a table, and on the table you basically define a column description, and you keep on adding more and more columns to your table description. Okay, this table descriptor will contain all the columns, and once you are done with defining table and columns, sorry, column family, not columns, then you say create the table, which means for creating a table you needed the name of table as well as the at least one column family. Okay, because if there are no column families you can't add any data, because every column has to be added to a column family. You cannot add column families later point of time. All right, so once you have, and the other way is you can ask H table description to give you the name of the table, as well as admin can give you the list of tables, and you can basically, here the next step it's doing is it's checking in the list of tables whether the table we wanted to create has been created or not. Okay, and once the table is created here, it basically it creates a row key. Basically it created a bytes row key, then created something called put over each row key, and then using this put p1, it added the data to the table. Okay, so the only thing which is no uncommon is this put variable. It's basically a class which is created over each row key. Okay, and so on. All right, all right. So for each row, which is P1, represented by P1, we are adding more and more data. Like here, there is data, comma 1, comma 2, value 1, and so on. And that's all. Alright. In the similar fashion, you can also do get. And if you want to do map reduce on top of HBase, you can use the following format. Just like we defined earlier, you define a mapper, this time extending table mapper, right? And then implementing map function. And after that, you define something called my table reducer after extending table reducer. And once you're done with that, you bind everything using the HBase configuration. After that, you can do start the mapper job. Okay, start the mapper job and wait for its completion. Sounds good? So this was using Java API. How can you talk to HBase? Okay, this code is good enough. I think rest of the things you can anyway look in the Java library and you'll get the fair amount of idea. Now, if you are a REST kind of person, you can utilize this kind of format. Okay, it provides you the API format using which you can basically query from the browser itself by providing table name, row name, column family, column name, and then the value name. Okay, so and so on. This is put, but if you're getting, then you don't have to specify from here only up to here. Okay, like this. All right. If you are interested in working with JDBC and HBase, then probably phoenix.apache.org is way to go forward. Now, somebody asked me about a Bloom filter. Bloom filter is a very interesting data structure. Bloom filter is really interesting data structure. Why? Because it provides you with the ability to bring down the load on your searching. Every database suffers a load of searching in the database, right? And HBase is not an exception. Okay, so bloom filter as as a concept has come from search engines, and it is basically a statistical way of figuring out how to divide your traffic of search into multiple phases. All right, now let me give you a good example. So in in an organi- in a in an enterprise, there was a security person whose role is to find the ID of each person. Okay, so people come to the security person, and if the ID is not found, the security person does not allow the entry. Okay, it's a common thing which you will see all the time, right? So there's a security in every organization, and there are a lot of people who come and tell them, hey, my name is this, do you have my entry in the list? Okay, now the security person will open the register and try to find the name of this person as quick as possible, right? Now imagine, okay, imagine that the registers are 100 million. Okay, so even if you do a binary sorting, so the way it is generally done is the names are sorted by, just like a dictionary, the names of the people are sorted in ascending order, and you label that things starting with A is here, B is here, C is here, and so on. Each register has a tag of A, B, C, D, and so on. Now, imagine that registers are of, say, itself, total number of registers in which it has to look are, say, 1 lakh. Okay, now the load of the security person is humongous. On every time a person comes in, it has to first locate which register it is and then find the name of this person. Now, on each person, on each person, it is spending maybe hours just to figure out whether he is there in the list or not. Okay, now now there was, so what this security person did was he said, I have a plan, let me hire one more person who will be my assistant. Okay, who I will give first two letters code. Okay, so we'll prepare another register, another register which will only have list of, another register which will have list of first two letter code. Okay, it has for a big register containing only first two letters. Now you can imagine that how big this list be. Can somebody tell me how maximum, how big this list could be? If we form a list of only the first two letters, how is, what is the letters as in alphabetic letters, not numeric? How? No, it can be A, it can be AB, it can be AC, and then you'll have by the end of it JA, JB, ZB, and then up to ZZ, right? How many are there? Count. Okay, count of these. How many? 26 into 26, right? Because there is no such rule that we can't have BA as well as AB, right? So, which is I think 576, 676. Okay. So, it's just a small list of 676, right? Now, the beauty of, hello, can you hear me? All right. So, the beauty is now it prepared another register, okay, with another person. So whenever a person is entering the gate, it has to go through this person first. Okay, and this person will quickly check in this small list. Okay, this person can quickly check the first two letters of the name and then immediately reject or accept. Okay, so lot of load, lot of rejections will happen here. Okay, because the first security person said that, hey, lot of people come to me who are invalid. Okay, it's just a overhead on my head. Can we just sanitize quickly? Is there a way to do it? So this another person immediately looks up in these 676 names and then say, oh, this guy is rejected, this guy is rejected, this guy is kept, this guy is rejected, and quickly the load reduces to low, very very small. And in case it finds that, oh, this name starts with AA, then it sends ahead, and then the real check by that first security person will happen, where it will look up the full name instead of only first two letters. This is exactly what we call a Bloom filter, right? Instead of this two letter code which we have given, we always come up with something called a hash code. We always come up with beautiful hash code. We come up with numbers. Okay, we say for example, sum up all the letters, ASCII values of all the letters in the name, and then percentage it by 26. Okay, so we have at the end of it, we have only 26 numbers. So using hash code, we can convert huge list into small numbers and immediately reject or accept people based on this. Okay, but we can immediately reject, but we cannot immediately accept. For accepting, it has to go through the real check, right? Say in our database there was a person called Abhishek, right? If if person called Sandeep comes in and so SA is not available, so the answer would be reject immediately. The first guy will reject immediately, right? If a person called Abhinav comes in, okay, Abhinav is represented by A, and the first gatekeeper will accept him, and then second gatekeeper will reject, okay, because Abhinav is not there, there is only Abhishek, right? So this is what we call Bloom filter. Is it clear to everybody? In another way, there is a Bloom filter. There is a query comes for key 1, Bloom filter rejects. In case query comes for key 2, it says yes, and then it goes till the endpoint. Here it says yes, we have found key 2, but for key 3, this person might say that the filter might say that yes, it is, we have key 3, but when it goes to the last point, then it might get rejected. Okay, so it, the Bloom filter will not give false negatives, but it will give false positives. If it is negative, that it is 100% sure that we don't have that data, but if it is positive, we are not sure whether we really have it. Okay, all right, sounds good to you. So Bloom filter is employed by default into the HBase table. Okay, so let's have a quick look at how does HBase look like. Okay, let's have a quick look. How does HBase looks like? Let's, all right. So we have got, so Bloom filter is clear to everybody, and Bloom filter is not something very specialized for HBase. Bloom filter is a general paradigm, and it is used at lot of places to statistically uh, reduce number of lookups. Now, okay, so HBase is running fine. Okay, now we can go to the server. So to start HBase, we say HBase shell. Alright, now HBase shell is there. To first of all, you should check HBase status. There are two servers, one is dead, and which one is dead? Let me check. So one of the region servers out of three is dead. So as soon as the one of the services will come up, let me again go back. What is wrong with this? Is it logged out or something? Why is not logging? It's down. Service Ambari server start. I need to log in as admin. Never mind. I think still. I don't know the password. Let me take off my screen for a minute, and then I will, because I need to enter the password. Now all are up now, and we can say we can create our table using a simple command called create my table and my column family. I think the table already exists. So let me say create my table ITC, and my column family is my CF, and that's it. Right? Now you can see list, you can see my table ITC is created. All right. Now if I want to say ls star ITC, for that I'll have to say this list. So you can, not this, you can see. So then if you want to put something into my table, and I want to say this, I will have to say my table ITC, and I have to give a row key, and then whatever column family I have defined, I will be putting data into that column family and a value. So I'm saying into my table ITC, put the data into a row called row 1, and my column name is mycf column 1, and the value is 1234. This is what I'm doing. Okay. And if I want to add one more column here, remember that I have not defined a column. Okay. And I want to put some column name, I can do this way. Okay. And list, and I want to see what is there inside my table. You can see that this way. You can see for row 1 column this one, the value is this, and row 2 column 2, and so on. This way you can scan over the table. Okay. If you want to get specific value, you can get specific value using using this. All right. You can see 1 2 3 you got, and so on. And for describe my table ITC, so it will tell you the full detail about the ITC. Okay, whatever the table we created, the Bloom filter is on. Bloom filter is by default on all the things, and we have you know if you want to keep a table in memory, we can also define that. Okay, so all right, now after that, in case you want to delete your table, okay, if you want to delete your table, what you have to do is first disable the table, and then you'll have to drop the table. All right, now that's all. Okay, so this is a very quick hands-on with HBase, and you should try it out by yourself. And basically, HBase is a data store, okay, where you can store a mammoth amount of data into a database. All right, and this all of this data beneath the hood is stored in HDFS, which means you get all the features combined with the HDFS features. All right. Now, that's pretty much about HBase. Do you have any questions on HBase? No. You cannot have the rollback and commit kind of thing in HBase. Either whenever you are committing, either it happens or doesn't happen in full. If you are doing an operation on the whole row, either it happens or doesn't happen. Okay, there's a guarantee. Only there will be no intermediate uh, uh, step. Yes, HBase is on the top of HBase, HDFS. So, yeah, it doesn't provide you that kind of functionality, but I think it provides you a functionality of, I'll show you. So, you have help scan. Okay, so it provides you put, truncate, preserve, scan, get counter, get, delete, append. So, it doesn't provide you a lookup by, if you see help scan. Okay, so basically no, it doesn't provide you all that functionality. What it does it provide you is you look up for a key, look up for key, and all the keys afterwards of that particular key you can continuously read using scan. So basically logically, as I demonstrated to you here, the data is actually stored in HDFS. You remember this is our HDFS interface. Data is actually stored in HDFS in this form. Okay, not logical, but it's actually physically on HDFS. All right. So data update, the way it does is it basically drop the whole table, whole file here physically the whole file is dropped and then created again. Okay. Whole file, as in when I say whole file, it means a single block containing that particular data is dropped and created again. Because HDFS is mostly like an append only database, append only file system. Okay. All right. So to update our data, what does it do is it generally drops the blocks and then create those blocks again. And essentially it's like a new file for HDFS. Okay. HBase has single column value filter. There is no filter. There's only scan provided to you. You basically whenever the filter which on application library, the way I demonstrated to you, there is a phoenix.apache.org. Those basically what they do is they scan the database and then gives filter it. Okay. So when to use HDFS and when to use pig or hive. Okay. Okay. And Pratik is also asking the same question. Okay. And what is the maximum recommended cell size? Cell size can be anything. Cell size can be anything. It can be a gigabyte. Okay. Because for cell size, that there will be a HDFS file is going to be created, and HDFS file can be of mammoth size. Okay. So let me just differentiate between pig, hive, HDFS, HBase. There are four things. So there is no alternative to HDFS. Okay, it's like saying, can Microsoft Excel replace C colon or hard drive the FAT32? So HDFS has to be there. Okay, so every data is stored in HDFS, whether the data is in HBase or data is anywhere, the data always goes to HDFS. Now HDFS is like a file, big file. It could be plain text, and every time in HDFS, if you try to create records, it is quite a big problem. So you can imagine that if you have a big HDFS file, you want to delete one particular row. Okay, what you will have to do is you will have to copy this file elsewhere except for that particular row which you want to delete, and that's all, and delete the old file, which is heavily clumsy which is heavily clumsy. To avoid such kind of circumstances, HDFS has come up with, HBase has come up with row key, column key. For each row key, there is a separate file, and so on. Okay, so if you want to modify a row, only one small file is going to be deleted, and it's not going to impact other rows, right? That's what HBase is doing for you. If you have a lot of manipulation of a single file, okay, then HBase is a far superior solution. Also, in data in HBase is also structured. It's not completely unstructured. It is structured. It is sort of semi-structured because we don't know the data type of individual value, right? So therefore, whenever you have to store data which is fairly dynamic and it has got humongous rows and humongous columns, and you want to keep it, all the time available to your program. Yeah. If you want to just jump to a particular value quickly and those kind of things, or you want to delete a particular value quickly, the HDFS is not sufficient. For that, you will require HBase. Okay, because HDFS is like full file. You can imagine that if you have stock prices in full file, if you have to delete couple of rows and update couple of rows, it is actually scanning the whole file. But if you put it in HBase, you can quickly access using row key and find that particular column and delete it or update it, right? That is the difference between HBase and HDFS. Now, why Pig and Hive? Pig and Hive are great tools to static data, analyze static data, right? So instead of you keep on reading, understanding HDFS file and then running a MapReduce on top of it, you can actually use SQL like query to query your data. Okay. And similarly, using Pig and Hive, you can query your HBase and do the job. All right. So all four things, only it's only Pig and Hive who are competitors, who compete with each other. Other than that, you have these three things fairly clearly separated. HDFS to store unstructured data, HBase to store fairly structured data and highly dynamic data. Okay, while your Hive and Pig basically help you query HBase and HDFS using SQL kind of language. So am I clear when we talk about HBase and HDFS and Pig and Hive? Can we use HBase for real-time processing? So the answer is yes and no. Okay. Real-time processing demands the time latency of milliseconds, and that's why we call it real-time processing, right? Whenever data is coming at a stream and you want to process it parallelly on multiple computers, then for processing the data in HBase, you okay, for processing the data in HBase, you would require MapReduce. And for doing that, doing MapReduce, as we all know that MapReduce has got latency, and hence that does not become a good solution for real-time analysis, because MapReduce has got a latency of few seconds, which is going to hurt you pretty bad. And the design of MapReduce is such that it is good for resilient computation, but it is not good for real-time, but maybe little bit wrong calculation. Okay. So therefore, it doesn't suit, it doesn't, it is not a great solution. HBase is not great solution for real time computation. A real time For real time computation, you need to use storm storm or you need to use storm, or you need to use spark. All right. Okay, then. So how do you define? Okay, can we set the separate replication factor to store files? Yes. And I think create database table gives you that syntax also to create that. But in case it doesn't, what you can do is after creating your table, you can use a command called Hadoop. Okay, and you can see set rep. Okay, set rep basically. Okay, so here you can see in, let me, you can use a set rep here, like this. Okay, and if you put capital R, then basically you can set for the whole directory. Okay, you can say set rep, and then you can specify minus w for, if you specify 4, and you will get more replication. All right, now, all right, so next question is Google search using NoSQL. So yeah, so why Google uses big table? They have exactly alternative of HBase. The overall idea about big table is to store humongous data. So lot of data at Google is stored in big table. Almost all of the data, even the compute engine runs on a minor variation of HBase, of big table. Okay, now in this one specifically, the big table was designed for crawler data, and that idea, that whole paper basically tells how to use that. But real-time querying is not done using this. Basically, it is, the data is lying here, the data is lying here, the querying happens via multiple other systems. This is good when you're storing data, when you're doing a lot of batch processing. For example, you want to compute various kinds of ranking of various websites. Then you will run batch jobs using MapReduce, and parallelly you will do a lot of analysis of words and all of that using HBase only. Okay, so that's where Google uses it for searching. How to define coprocessor for HBase? So that is something which is not yet included. Again, let me just add that to my to-do list. Okay, so I'll cover it maybe a little later in the session. All right, don't worry about that. So this is the third thing which has been added. All right, okay, so any other questions? Let me take a proper note. How to define coprocessor? Any other questions other than this? What is poly polyton persistence? What is polyton persistence? Okay, so you mean to say when you want to store data to multiple data sources, you mean polyglot kind of a data, right? So that is something you have. Polyglot persistence is something you need to do on the application layer. Okay, that you need to do on application layer. And if you are writing in Java or some other language, you can easily do that using HBase. The only problem with that is that in case, eh, basically you will have to manage the transactions by yourself. Okay, you cannot have a single transaction containing all these 3 4 things. Okay, so secondary index add-on is not yet available. Maybe I'm not sure if it is available, but It was not available as per my knowledge. Okay. Similarly, in case of Cassandra, they themselves started providing secondary index soon. But the first primary index is generally your row, second index is column. In case you want to create more indexes, you generally create another table containing a key and the value, and that's all. Okay. Second index basically will contain a key, some other key, and the row key as the value. All right. Any other questions to me? Karthik, was I able to give you answer? Purushottam, Karthik? So after this session, you must be getting an email with the form to submit the reviews of the classes. So it will be great if you provide the review. All right. So Anjana must have been sending you those forms, and please provide the review that helps us improve as well as address if I could not answer few things or there are few things we might have to improve. So it'll be great if you please provide us feedback. All right. So thank you very much, and feel free to drop me an email if you have a question. Great, great. Thank you. So it was a great set of questions. Please feel free to ask me more questions. All right then. Bye bye. Have a good day.